Welcome, my dear students. Today we discuss about controllers in IoT system. Master the essential hardware platform and a programming foundation for embedded system and IoT applications. The programming foundation is mainly classified as a fundamental languages, the C++ programming, Python programming, Linux operating system. Low-level C++ programming mainly focusing on low-level hardware control with object-oriented design pattern for efficient embedded applications. And then Python programming is a high-level scripting for rapid prototyping and data processing in IoT system. Linux operating system, one of the old operating system, they have command line interface and system administrations for embedded Linux operating system. Both programming is essential to control the IoT systems. First, we discuss about the Arduino platform overview. Arduino board is classified Uno R3 is a beginner and friendly. Arduino Nano is a very compact design for applications. Arduino Mega, it have expanded input and output pin as compared than compact and the beginner board. Arduino Pro Mini and minimal footprint. It's a very small size as compared than Arduino Nano. Some key features about the Arduino platform. They have the open source hardware platform with a simple programming interface and perfect for learning embedded system with extensive community support with the help of libraries. It is a built-in ESC programming interface, eliminate need for external programmers. And the Arduino development environment, it commonly is have the 4 steps. First, you can install Arduino IDE steps, the open source environment, so it is easily available to download and install the integrated development environment with a built-in compiler and uploader. And next we discuss about the board configuration. Select approximate board type and computer port for seamless code deployment. Library management. Insert the sensor library and third-party extension through the library manager. And finally, we need to upload the code. Before the code upload, we need to compile and upload sketches directly to the Arduino board via USB connection. And we need to discuss about the EPS 8266 Wi-Fi integration. This is the wireless connectivity. The ESP8266 module transform Arduino project into the connected IoT devices. There are some features built within the TCP and IP stack and Wi-Fi capabilities. We have station and access point mode, HTTP client and server functionality, MQTT protocol support, over-the-air updates. The ESP8266 Wi-Fi integration is required the 3.3 voltage with the 240 milliamps peak current during the transmission. This is essential for connectivity with the Wi-Fi. And we discuss about the next Raspberry Pi platform. Raspberry Pi board and the peripheral add-on community Raspberry Pi OS. Raspberry Pi board is a full Linux operating with a general input and output pin, and the PI4 offer quad-core ARM process. They have high process capability, and then peripheral is a camera module, HAT expansion board, and specialized sensor breakout extends functionality. Raspberry Pi OS it is based on the Debian-based Linux distribution optimized for PA hardware with GUI and command line tools. Next, we discuss about the essential sensor integration in both Arduino and Raspberry Pi. Bus LED and push button. It is a digital output control with a pulse width modulation dimming and a debounced input reading for the user interfaces. Next, the light intensity sensor. LDR or photodiode circuit measure the ambient light level for automatic lighting systems. Ultrasonic sensor is to measure this distance. Generally, we can use HC SR04 sensor provide non-contact distance measurement using the sound wave time of flight. Next is the temperature humidity. DHT-W2 digital sensor deliver calibrated environmental reading via signal wire protocol. It gives the subpatterns, sensor and actuator interaction pattern. First, sensor read the data, process and decode. It should be generate some code. Actuator and respond because transducer to execute our requirement. Let's discuss the practical implementation example. Smart home controller, it gives temperature sensor, trigger heating system, motion detector, activate security lighting systems. And we discuss about the automated plant care. It should measure the soil moisture sensor, control the water pump, the light sensor adjusts the glow lamp intensity. Access control system, RFID reader, radio frequency ID reader, unlock the servo control door, ultrasonic sensor detect the unauthorized entry in the garden. This is a practical example of a Raspberry Pi and Arduino board. Next step is to be control mass tree. We have megastructures, build practice project of this smart and simple LED control, then progress to multiple sensor, weather station and home automated systems. Explore communication protocol. We have the master 12C, master I2C, SPI, what interface for advanced sensor integration and device communication. Development of IoT platform in application very important because connect your project to cloud platform and create the mobile app for remote monitoring and control. It is a few example and a few implementation of IoT controller in our day-to-day life. I hope students you have a clear understand what is the programming languages and then IoT system, especially for Arduino board and the Raspberry Pi. Thanks for listening for this video. Thank you.